Hello, beloved friends. Welcome to today's class. So, in this beautiful question, we're asked to find for x and y such that x and y are members of positive integers. So, let's write down a solution. So, we have x squared minus y squared or 65. And you know this difference of two squares, and when we have this a square minus b square, it can be written as a minus b and a plus b. So our a in this case is x and our b in this case is y. So substituting this here, we are going to have x minus y, x plus y as 65. So if this is what you have, note x minus y times x plus y is 65. So that implies we need to find the two factors such that x minus y and x, if we multiply it with x plus y to give us 65. And what are the factors of 65? The factors of 65, we know 1 is part of it, we know 5 is part of it, 13 is part of it, 65 itself is part of it. So 1 times 65 is going to give us 65. So this is another one case. So 5 times 13 is still 65, and 13 times 5 is still 65. 65 times 1 is still 65. So if this is the cases we have, note x minus y should be less than x plus y. X minus y is obviously less than x plus y, or you can say x plus y is greater than x minus y. So but for this case, we can actually see that x minus y is less than x plus y. So that means considering this side as our x minus y, so this satisfy the condition, because since we are considering this first part as our x minus y, and also this satisfy the condition because we can see that the first value is less than the second value. Same here, the first is less than the second, but here no, this case won't hold because x minus y cannot be greater than x plus y. So these are the two cases we'll be using. That is, this first value will represent our x minus y, and the second value as our x plus y. So now the two cases that will hold is this. So now this is what we are using. So for this case 1, which is 1 times 65, which will give us 65. So now our x minus y is equal 1, equation 1. Then our x plus y is equals to 65. Let it be our equation 2. So adding 1 and 2, we are going to have 2x, because minus y plus y is 0, equal 1 plus 65 is 66. So this is what we have. So now dividing both sides by 2, we are going to have our x as 33. So substituting in 2, substituting in 2, we are going to have, let's write down our equation 2. So our x is 33, so we have 33 plus y equals 65. So if this is what we have, so making y subject formula, we're going to have 65 minus 33, and y is equals to 32, which implies for case 1, our x and y value are 33 and 32. And both of these they are members of positive integers. So let's check for case 2. Case 2, such that we're going to have 5 times 13 equal 65. So if this is the case, so now which implies x minus y is going to be 5 and x plus y is going to be 13. Let's name this equation 1. Now let's name this equation 2. So now adding 1 and 2, we're going to have 2x equal 18. So dividing both sides by 2, divided by 2, we have our x to be 9. So now let's substitute this in equation 2. Let's substitute this in equation 2 and find. So now substituting x as 9 in equation 2, which is this. So now 9 plus y equal 13. So this is what we have after substituting it, and our y is 13 minus 9, and y is equal 4. So which implies for case 2, x comma y is equal to, our x value is 9 and y value is 4. So now let's check if this is correct. So checking if this is correct, remember our equation, we have x squared minus y squared equal 65. But to make it easier for us to check, let's write it as x minus y and x plus y equal 65. So now this is what we have. Now let's write down the value of our first, so x1 and y1 is equal to, no, the first value of our x is 32, our x value is 33 rather, then our y value is 32. So and our x2 and y2 is 9 and 4. So now let's check for case 1. For case 1, we use both this and this to substitute in x minus y and x plus y. Let's see if it will be equal 65. So what's our x? Our x is 33 minus 32 into the bracket of 33 plus 32. Let's see if it will be equal 65. So now from here, this minus this is 1 times this is going to give us 65, which is, so now we can see that 65 is equal to 65. So in case 1, as x minus 1 and x1 comma y1 is actually 33 and 32. So for this case is correct. So let's check for case 2. For case 2, when we have our x2 comma y2 as 9 and 4. So substituting it into x minus y and x plus y. Let's see if it will give us 65. So x minus y. So we have 9 minus 4 into 9 plus 4. Is that going to be 65? What is 9 minus 4? 9 minus 4 is 5. So 5 times 9 plus 4 is 13. So we can see that this is actually 65. So now this is 65 equal 65, which implies this is correct. So thank you for watching. Ensure you like and subscribe. Thank you.